Yeah.
Okay. Uh, is my camera seen? Am I seen?
Yeah, yes, sir. Yes, sir.
Okay, let me check about the sharing.
Sir, I think now the camera is off actually.
YouTube can be seen, sir.
Yeah, I can see the content, but the camera is off.
The world's most successful brands use material handling and logistics solutions to gain a competitive edge by improving their supply chain and customer service efficiency. They know that the strategic application of material handling and logistics equipment and technologies provide them with the edge.
Yes, sir. The audio is also clear, sir.
Cost service.
The sharing is working.
Audio.
For which you
Yeah, yes, sir.
What about now?
I guess the audio is not played now, sir.
Audio is not there?
No, audio is not there. Probably while you share itself, that audio option should be enabled and then shared.
Yeah. What about now?
Yeah,
There's two major
now, sir. Yeah.
The first
Audio
project
also.
students do as individuals,
Clear,
and the
sir. The audio is
second
clear.
The first half of the class is called the Hopper Project, in which each student has to design for themselves
Sir, shall we start, sir? Sir? Sir, shall we start, sir?
Is my audio good enough? Are you able to hear me well?
Yes, sir. Yes, sir. I'm able to hear you, sir.
Okay. Loud and clear. No problems, correct?
Yes, sir.
Okay. I just wanted to check whether the audio volume is good enough or not. If it's all right, then okay, let's get started. Not a problem.
Sure, sir. As of now, we have around 1,220 students, 250 students already attended.
Okay. Okay.
Yeah.
Sure. Shall I get going?
Yeah, yes, sir. You can share the contents.
Okay. Good morning, everybody. I'm Naimullah Khan, professor in the School of Computer Science and Engineering. You may have seen me earlier in a presentation on academics also. What I wanted to discuss today was what you can do for yourself during the course. Okay. Do it your okay. Balasundram, are you having an ability to ask a question, answer, chat, or something like that? That's also enabled?
No, Q&A is enabled, sir. Just a minute. Let me confirm if you are going live, sir. Just a minute, sir.
It shows live.
Yeah. I've resent you live again. Just wanted to ensure it is going live.
Okay. So good morning, everybody. Nice to have you here on a Saturday when probably you okay, over the past year and a half, probably you had your Saturdays off, Sundays off. Once you are in campus and once you join in any institution, academic institution, especially VIT, all days are busy. Saturdays are day to work on your projects. Saturdays are days to work on all topics that you've been doing. Saturdays are time to freak out. Saturdays are time to have fun. That is time to go to city if you are in the campus. And you can, of course, in the first year probably you will not go to the out to the city. But anyway, the point is, Saturday is time for a lot of things. All right. So in that sense, this Saturday we are going to keep you engaged early in the morning with something that's happening. Okay, something that you could do during your stay at VIT. Something that not you could do at almost every aspect of your courses, in every course, in every part of your academics. All right, so that's the point that I'm trying to convey. Okay, so when we say do it yourself, all right, when we say do it yourself, you would have seen your do it yourself kits, correct? Just a second. Yeah. When you see a do-it-yourself topic, what generally comes to our mind is do-it-yourself kit. Okay, so you would have. I'm not very sure how many of you have purchased a do-it-yourself kit of an airplane or a car or whatever it is, or even a remote-controlled car. Okay, so what do? You take your, you get all the parts that came along with the kit, and you build that kit, assemble that kit and build the product that you actually bought. Let's say a model aeroplane running on a rubber band power, all right? So that could be one of the things, all right? So what do? You take the components that maybe if it is an aeroplane, the aerofoil may not, the wings may not be well smoothed out. Maybe you put sandpaper to it, design it exactly in the shape of an aerofoil, then put the pieces together, the propeller together, tie the rubber band. I'm not very sure how many of you have seen or flown aeroplane propelled by rubber band. But you could get your propellers done, and you could spin up a propeller. And when you see the flight of the aeroplane, okay, then's when you get your thrill. Right? Correct? It flies. My God, what I put together flies. Okay. Even in school, you would have done this paper rockets, correct? Paper aeroplanes. You've all done those stuff. Okay. So when you make a paper aeroplane and your friend's paper aeroplane, he also makes one and yours flies further. That's where the pleasure comes. Correct. You are able to do something. You experience the success of the flight and the experience of success when it beats your friend's aeroplane also, paper plane. All right, so that's really a pleasure that you have. All right, you remember that for a long time to come, isn't it? So that's the best part of that do-it-yourself stuff that you do. All of us. Probably almost all of you would know how to ride a cycle, correct? Bicycle. We are all comfortable with riding bicycles. But when you first, your parent, probably father or mother, whoever was helping you out, or your friend who put you on the cycle and you pedaled yourself. And did you get it right the first time? Probably not. You would have fallen down, you would have done hours and hours of practice for you to get your balance. You would have fallen many times. After the fall, you did not give up. You got up, you practice again, fell again, but ultimately you mastered. And once you mastered, even 20 years you don't touch a cycle, 20 years later you sit on the cycle and ride a cycle, you will be able to balance yourself and the cycle will go smoothly. So what's the point I'm trying to make? What you learned by doing stays with you. That's all the point. Okay. What you learned by doing stays with you. Yeah, you can study subjects, you can study theory, you can study things, certain concepts. Yeah, you may remember it, but what comes by experience is much more tangible. You see that and it stays with you, you enjoy it, and it's unlikely that you'll forget those type of skills that you learned. All right. So that's exactly the point we are trying to make today in this session. Okay. So what is it there in store for you at VIT? So basically, your curriculum, so you are into a new curriculum where you have seen your curriculum shared by your head of the department. You have so many courses, and in some of the courses you have a component for almost all the courses. You have internal assessment component about 30 marks. Which is for digital assignments. All right, so we call it digital assignments to give flexibility. But that 30%, some of the faculty, not all, some of the faculty will let you do a activity-based learning. Okay, so you can do some activity. So depending upon the course and the resources you've got and facilities that you have at home or on the campus, you may do a hands-on project. Okay, so the activity that you will conduct is a project. So what do you do? So how does it go? Basically, let's say you study this semester, you're studying physics. All right. What happens when you study physics? You come across certain concepts on waves or lasers or whatever. Those are some of the topics that you've got in your physics course. So let's say lasers. All right. So what do I do with a laser? Okay, you can buy a 100-rupee laser in a fancy store. All right. Now, what can I do with it? Okay, I will tell you an experience of a student I knew. Okay, what did the student do? They had also had a Arduino board. All right, they had a basic vanilla 1,000 rupee Arduino board, and this was a 100 rupee laser from the store, and they connected together and created a burglar alarm. Right? Arduino board based burglar alarm. So you would have seen in those movies, correct? Old time Hindi movies and all you would have seen, or even in old fashioned Western movies, a person will go to rob a bank or a building, okay, and you'll see the red color razors here and there. Okay, he will use some colored goggles, and then he will escape the lasers and go and steal whatever he's trying to steal and come back. Okay, unscathed. So that's the point. Okay, so the point was so a simple laser and a simple mirror. Okay, so if I have to cover the entire room, I have to, let's say, I have to cover the perimeter of the room with laser protection. All right, meaning it's a burglar proof. So any person crosses the boundaries, 4 boundaries of that room, then the alarm triggers off. So how does it happen? So basically, the person took a room, simulated a room, and put mirrors in all the corners. One laser light goes all over the place, and the moment you cut a laser beam, the signal doesn't fall on the sensor that's concerned. Off, all right? So let's, and to make it still smarter, it was he connected that laser, so Arduino board. He put an SMS, GSM controller, GSM board on that Arduino board. All right. So once the GSM board was there on the Arduino board, he was able to send a signal, an SMS, to the mobile phone of the owner, house owner. Okay. So what happens? The moment the laser beam is cut, it means there's an intruder. A call will go and an SMS will also. So both the phone call goes. So the moment the owner sees there's a basic intruder is there, and the phone call alerts repeatedly, 2 or 3 times it happens. Simple. Arduino board, if you have one, 1,000 rupees worth Arduino board, and a 100 rupee worth laser. And what you have? A demonstratable physics based experiment, laser physics, and off you have a viable solution that acts as simulates a burglar alarm. Right? So it simulates a burglar alarm. And what you have done, you also used the knowledge of your mobile phone, how a mobile phone works. In this process, what all has happened? So you have learned physics. You have learned how a laser gets bounced off. You have learned how to use electronics on the Arduino board and a GSM controller, basically a cell phone based device that helps to transmit messages or a phone call to a remote person. Right? So all of that happens in that thing. Maybe if you spend how many days? Probably 4 or 5 days is all is required to get a hang of it and implement it. Okay? So maybe you can do it faster also. Okay, so what you don't know, it's basic programming. So what probably you learned in school or what you're learning in the first semester now in Python, that sufficient basic loop is all that's required. Okay? So what am I trying to tell you? The point I'm trying to tell you is that activity that you do as a physics experiment. So what you studied lasers, you implemented it, and you've done some tooling and demonstrated a prototype, because of which you are able to, what's happening? You're able to learn hands-on. So that concepts of integrating hardware, electronics, mobile, then some physical equipment, mirrors, all right, and demonstrating to your faculty or your student, showing that it works. That stays how you follow. So that's the best part about all of our experiments. All right? So that's what we want you to do in every aspect that you are doing. So the point is, in doing courses, in your current curriculum, you will have to initiate some of these activities. Some of the activities will be initiated by the faculty. Okay, so it depends upon the course and the faculty. So that 30 marks of your digital assignment may be offered as a project-based, activity-based learning, because of which you can implement something and you can score marks. Or it will be, in some cases, it will be just a general assignment, write an assignment and give it, or a quiz to happen. That can happen. Okay? But if there's an opportunity to do hands-on project-based, do-it-yourself task, then definitely do it yourself. Okay. So the point, how do I connect all of this? Okay. What's the point? Suppose I take a paper and write a few things, whatever the rubric the head of the department or the faculty told. I'm able to do whatever I need. Okay. But what does not happen? Okay. Does not happen is that you don't get mastery, you don't get opportunities. Okay. I will show you just a minute. What I will do is I'll lead you through I'll just hand you. Yeah.
Yes, sir. Sorry to interrupt, sir. The Q&A is actually disabled, sir. Actually.
Oh. Oh my.
Yeah, like I was just checking if I could enable it while the session was happening, but it should have been done even before that. Actually, it should have been pre-configured.
Okay.
Yeah, that's the thing. I just wanted to let you know on that.
Yeah, no problem. So let me share something. Okay. Share the screen itself. Okay. Are you able to see the screen now?
Just a minute, sir. I'll send it live. Yes, sir. It is live now, sir. You can play.
Okay. Okay. Some of you may have seen the movie called Karate Kid. All right. I'm just showing you some small clipping. It's about 9 to 10 minutes of a movie, parts of the movie. Okay, I have some points to make at the end of the movie. Actually, I would have like to have a live interactive discussion with you on what's happening, but that is not possible now. So let me just walk you through what's happening. So basically, this is a clip from the Karate Kid movie. All right. So what's happening here is there is this guy. This is a student, the kid who is coming to. He has a problem. As and when the video goes, I'll probably tell you what I want you to hear or concentrate on during the clip. Okay. So this is a guy who's showing up on a. He's living in some apartment and he has a leaky water faucet at his home, and so he is coming to complain about
Hey,
that.
the maintenance man.
Is the audio clear? Are you able to hear the audio?
Yeah, we're the people
Yes,
apartment
sir.
20.
Okay.
Yeah, faucet's really leaking there. Okay, you come fix it?
Hey,
Okay, tell my mom when.
when what?
When are you gonna fix the faucet?
After.
After what?
After.
So that guy comes to complain about a water faucet, and he's going. And this guy, the repair technician, is going to his home. There you see this student looking at a karate book and practicing.
Fix faucet.
Oh, yeah, come on in. It's the kitchen one. 1, 2, 3,
Karate.
4. Yeah. 5, 6, 7.
Notice the black eye on his left eye.
And a few months at the Y in Newark where I live. 9, 10, 11, 12, 13, 14, 15.
What happened, eye?
So, I fell off my bike. 18, 19, 10,
Okay, no hurt the hand.
2.
Notice he has a black eye.
Make sacred cut.
Okay, so point is that a student had a fight in the school with a bully, and he was beaten black and blue. Okay, so now he wants to get back at the person who hit him. He was a school bully. Okay, so he wants to overcome that. So he's practicing karate. Okay, but this technician also happens to be expert in karate. So he says, why don't you come? I'll teach you karate. All right, so that's the point. And he goes on. So this kid goes to visit the expert karate master to learn karate from him. Okay, so this is the first day. He says, okay,
That to
I'll
my
teach you.
You promise learn. I say you do. No question. That you part.
What does the master say? I will teach you. I karate teach, you karate learn. I say you do. No questions. All right. So that's the way. That's a deal.
Deal?
Steel.
First wash all the car. Then wax.
What do I have to watch all the car?
Remember deal. No question.
Yeah, but
Right. Wax on, right hand. Wax off, left hand. Wax on, wax off. Breathe in through nose, out the mouth. Wax on, wax off. Don't forget to breathe. Very important. Wax on, wax off. Wax on, wax off.
Hey, where these cars come from?
Wax on. Detroit. Wax off.
This guy just says, go and do this. Wax on, wax off the car. Okay.
Daniel-san,
What?
come here.
So what happens is that just a second. Will I have the? I'll just show you another part of the video.
Safe. Walk to no. Now ready.
Okay. So
Yeah, I'm ready.
I say
you're able to see the video.
out the mouth.
Yes. Balachandran sir, you're able to see that?
Yes, sir. Yes, sir. It is visible, sir.
Okay. So he keeps doing this wax on, wax off the whole day, whole night. Okay. Late in the night.
On. Right the hand, make the circle. Wax off, left hand, circle.
The master tells how to do that.
Right the
Okay.
circle.
So the next day comes. Again, he says, go back. The whole day he's not taught any karate. The whole day he's just working on this task given by the master, and he's gone. The next day he comes early in the morning to learn karate. The master gives him another task. That is to sand the floor. Okay.
Left the circle.
Wait, wouldn't it be easier going back and forth?
But you go circle. Right the circle. Left the circle. Right the circle. Left the circle. Breathe in, breathe out. Right the circle. Left the circle. Right the circle. In, breathe out.
Okay, so that's what happens. The next day, again, no teaching. The third day, it's about some other task. This guy is catching flies using chopsticks. You see the master catching flies with the chopsticks.
Wouldn't a fly swatter be easier?
Man who catch fly with chopstick accomplish anything.
You ever catch one?
Not yet.
So he says if a man catches a fly with a chopstick, he can
I try?
accomplish anything.
If wish.
Hey, Mr. Melody, look! Look!
So that was that needs speed, accuracy, and coordination to do that. Okay. The next day again, no teaching. Come back and
No sweat.
Fast you
to learn
accomplish
karate. Again, it comes back to the same point. Because this is another task. Paint the fence.
all in the wrist. Wrist up, down, wrist, all in the wrist. Up, down, wrong stroke. Very good. Up, down. No, look me, look fence. Up, down.
So he's teaching another task.
Then the wrist, down stroke with then the good, wrong stroke. Up, down, very good. Knee, bend the knee, come down. Up. Yes, very good. And your son, don't forget to breathe. In, out, up, down, up, down, up, down. And your son.
Also, same thing is happening, and it goes on and on. Okay. So, so what happens at the end of it?
Come here.
This guy says, I have come to learn karate and you have taught me nothing for 4 days or 5 days. It's actually more. And I am frustrated. I am going, I am leaving. I am not learning karate with you. Okay. So he has a fight tiff with the master and he goes. Okay. Okay. Maybe I'll finish it here. Okay. So he has his body bruised, his arms aching because of all the work and no karate. So that's the point that he's frustrated about.
Sand the floor.
I can't move my arm, all right? What are you doing? What are you... Ow! Ow, what are you doing?
Now show me. Stand on the floor.
How did you do that?
Stop!
Stand on the floor.
Hey, stand up. Show me stand the floor. Stand the floor. Stand the floor. Big circle. Stand the floor. Stand the floor. That! Show me pin to fence. Hey! That! Show me side to side. That! Show me sand the floor. Start! I always will come.
Just move on to that other part.
Show me sand the floor.
I can't move my arm, all right?
So what has happened? The master taught him some moves. The student was not interested in understanding the point, but he nevertheless went through the motions, and he is thinking he did not learn karate. But what has the master taught him is that the moves that are related to karate. Okay, but only the point is the student didn't understand when he was actually learning that aspect of it. Okay, so now when the master brings up a fight type of action and relates it with the action that was taught, sand the floor, paint the fence, that type of stuff, then he is able to relate it to it, and then a quick demo is what has happened.
Wax on, wax off.
Wax on. I say.
Okay. So that's the point that there.
Show me paint the fence. Show me side to side. Show me sand the floor. Look, I always look, I come back tomorrow.
Keep the focus. Come back tomorrow. So now the student it's like you first time you fell off the bike. Now you have a little bit balance, but you get the hang of it. So now this guy is hooked. So he thinks that, okay, I actually did something. And now he sees, and now you see the confidence in his walk. Okay. So the next day he comes. They are now off to a boat. And now the master teaches him something else.
Okay, here, stop. Throw anchor.
Drop the anchor.
Good. Stand about.
Stand on the boat.
No. Bow. Up.
What, up front?
Yeah. Make luck.
Stand on the
Left,
boat.
right, up, down. Side to side. Breathe in, breathe out. And no scare fish.
When am I going to learn how to punch?
Better learn balance. Balance is key. Balance good. Karate good. Everything good. Balance bad. Better pack up more. Understand?
Yeah, I understand.
So he's teaching him balance on the water.
You ever get into fights when you were a kid?
Plenty. Someone always know more.
You mean never touched it?
So he said it.
No.
So
Then quite train.
Like karate.
So,
So karate's fighting. You train to fight.
that's what you think.
No.
Then quite train.
So I won't have to fight.
Miyagi have a hope for you.
When am I going to learn how to punch?
And how punch. What's the matter? You some kind of girl? Punch. Not just arm, whole body. Hip, leg, drive a punch. Make here. Here. Give you power. That try punch. Good. Here. Once more. Good. Here.
So whenever you do it with all of it.
Very good, Daniel, sir. Good. Good.
Hey, pretty good. Look at this, Miyagi.
Hey,
What do you think, Mr. Miyagi, huh?
So the point is, when he talked about punch, put not only like a light punch, put with all your body, all your soul, all your arms, the whole weight. Whenever you're doing something, do in that sense, do with everything.
You got to be everything.
Okay.
I think you dance around too much. I think you talk too much. I think you're not concentrating enough. Lots of work to be done. Tournament just around the corner. Come, step out.
You dance too much. So that's something during training. Something else.
You fiber punch. You fiber punch like the sounds. Happy birthday.
So what happens? Then comes the tournament where he fights the school bully. So this is the guy he was acting, trying to fight, and he's trying to beat this guy. This guy is already a master. This guy is just trained out of the things. And during this, what happens is that this guy actually breaks his leg. Breaks, not exactly breaks. He damages his legs so that he's not able to stand on both of his legs. So he's one of where the balance that he learned on the board comes in place. And that's where the ability to work with the balance and wait for the correct opportune moment and give the punch that is required to knock down the opponent. Okay, comes the pleasure of success. So you put that effort, you put that punch, you put that concentration, you put that effort in your thing, you put your whole body, mind, and soul in whatever you're doing, then comes and if you imbibe all of it at the opportune moment. And when you actually need it, that balance comes, that power comes, that blow that finishes off or solves your problem. Okay, so that or the victory that you are desiring. So that is what is required. Okay, so that's the effort that you. So the point behind this that two things I want you to take in mind. When you are trying to do something, learning by doing it yourself, maybe you will succeed. But when you have a guide, when you have your prof helping you out, guiding you till, okay, take this step, take that step, take the step, and you go whole hog with the prof. Okay, you work with the prof, you understand what the prof is doing and implement what he is doing, then it is more likely you, along with the master, you do better. Okay, along with the coach, you win competitions. All right, so that's how sports happens. Along with the coach, you have your raw talent. All right, you have your raw potential. You have your ability to perform well. Okay, that is inherent in you. The coach only molds it. The prof molds it. He gives direction to it. He gives focus to it. He concentrates all of energy and efforts on a particular direction, because of which you do well and you win competitions. All right, so that's the key point about doing it and doing it yourself and appropriately being guided by a master, the professor, who will help you achieve your success. Okay, that's the key point about the whole idea behind this. Okay, if I do, okay, that's fine. That was all sports. That was some movie. So what's there in it for me? It Advedi channel. Okay. So if that's the question you have in mind, let me show you something else. Okay. Okay. Okay, this is a demonstration of a project done by students of the robotics club. All right, so these are mechanical engineering students. The club is run by Professor Arogya Selvakumar, the placement officer also. Okay, and this is a project that the students designed and built under his guidance.
Improving their supply chain and customer service.
So the whole point is how to.
They know that the strategic application of material handling and logistics equipment and technologies provide them with the edge they need to meet cost service demands, improve productivity and equipment.
So what they want to do is to design a transporter object. So I just skipped a few seconds, and this is what is
the transporter.
So the students came up with a transporter robo. Okay. So we have AI and robotics students also, and any student. Basically, it could be any branch of student can work on robotics. So all of you can have a hand on this. Our own school has its own robotics experts, and there are many clubs that also do this, like in the mechanical engineering branch.
Transporter improves supply chain forecasting, resource allocation, product planning, and production, while enhancing product visibility and tracking, ensuring quick and accurate delivery.
So this is how they conceptualize the components that go into their robo, the transporter. Okay? So this is how their work is. So they went ahead and created they cut their equipment, built their equipment from scratch. The parts, they're getting it cut and welded. So all of it is happening at Chennai. This is the basement lab at ground floor AB2. Time-lapse video of them assembling the entire system. Okay, I'm having a slow network connection. Am I audible now?
So you are audible, but the video is like sort of buffered actually.
Okay.
Maybe
is it now better?
Yeah, it's better now, sir.
Okay. So every part is assembled together. So this involves planning, design, the components, like this case, what electronics goes into it, what control mechanisms go into it. Okay. So this is where you will have some expertise that you studied in the class. There is something that you don't know. There is something that your senior student may know. So that's where you work together with your seniors and your juniors and the prof. Okay, it's not that you know everything from scratch, all of it on day one. No, definitely not. But you have friends and students and professors who work on all of these. They are able to help you out in putting them together, the design together. Okay, so now look at how it's actually working. So this is the actual demonstration of the work of the students. Okay, so they've assembled it and it now does what it's supposed to do. So whatever is there in the pallet. Okay, so basically in a factory, all of these things will be arranged in boxes or in pallets, like the demonstration here. So that's the robo that is moving the transporter that they designed from ground floor to a first floor assembly, goes to derive it to a travelator where it gets done. Picks up some other objects from some other store, brings it and delivers it somewhere. So this is just a possible solution in which things will work. This is how things will work. So that's the whole point. These are the students who actually worked on that thing, guided by Professor Arogya Selvakumar. Okay, so that is what is possible. Okay, so that is all you can do. That's just one example. If you look at okay. Now let's come computer science. So that was robotics. Okay. Now you all let's think computer science. What can I do? I don't know all of robotics. Let's say, or I just now started learning programming. What can I do? So logged in into the Python programming course, correct? You already had probably logged in into vPropel. Most probably all of you have done that. Okay. vPropel has a is a mechanism in which you type in Python programs, compile it, run it, and get it done. Okay. In that portal, there's one component that's called that does plagiarism checking. So if you write a code and you share it with your friend and he submits as his code, okay, we have a mechanism in which we can compare two people's code one to one and then find out how much you have copied one from the other. Variable name x equal you write x and he writes y. All of that will get deciphered out. All right. So the faculty will get a list telling, okay, code A 100 lines, code B 100 lines. This 40 lines, this 40 lines, this the 20 lines are all same. Okay. So that is inbuilt. We have a open source plagiarism checker called MOS, all right, by Stanford. If I'm correct, it's from Stanford University. It's an open source code. Why am I telling this example is that a student, a second year student, after doing the first year Python course, the student joined the second year program, second year course, and he came to us when he was developing that, when we were developing this vPropel. We have faculties who developed this vPropel. He came to the faculty and told, ma'am, I want to, I've been working on this plagiarism detection. And I have looked at that MOS open source software for plagiarism. And now I am working, I have improved it and I have done much better than that. And the performance of this plagiarism checker is much better. So we actually tested out that plagiarism checker with the standard stock. And we've incorporated that plagiarism checker in our vPropel. So what's the point I'm trying to say? A second year student who is just fresh off Python works on a project that is of interest to us as computer science students, as well as computer science faculty. And he comes up with, he sees his friends, he does some good coding and he sees his friends copying and getting marks. He comes up with a solution to the problem. He approaches us as a faculty. We encourage him, we give him inputs on what to do, develops a product on in Python and Django framework with this happening in the background. The plagiarism checker is separately run. So the moment now all the faculty needs for the plagiarism checker and two codes will be exactly compared one with the other, and you get exactly okay 70%, 80%. That is possible. So what's the thing? He was not some employee of some, just a second year student, okay, who used his programming skills, the opportunity that was there, and the facility that was there. Use some ideas from the open source stuff, mixed all of them together, concentrated on a particular point, delivered a project, which is now a part of a product. Okay, so that's the good thing that can happen. So that is the capability of a second year student. So meaning to say, you can do it too. All right. So the point is only one thing. So to do it yourself project, to do a project, what's the first thing that you need is the desire. You should have a desire. Like that guy in the karate kid, he has desire to excel. He wanted to beat the school bully. He wanted to excel in karate in school level. All right. These students who did the project, they wanted to demonstrate. Okay, I didn't tell you the final outcome of that transporter project. They did that as a. They started off in the third year or something like that. Okay, they built that thing. They won a competition. They wrote a paper on that, so there was a research paper that came out of it, and the professor along with the student, they patented it also. So that one idea and that effort produced a research paper and a patent, all of it in the 4 years that they were there in the campus. All right. So that's the outcome that is possible. Okay. So it is possible. Right. So nothing is short. So the only thing was the desire to excel in that particular task. So they did it. No issues at all. Okay. So my point, what more can you do? Okay. Let me share what. So what is the limit? What can be done? What more can you do? I'll show you some completely different tangential product that is possible. I'm just showing you to show the possibilities. I'll just show you and then maybe I'll come back to what I wanted to say. Okay. So if you look at this, this is a video of a all-in college project. All right. All-in college is a university, a college in US. Okay. And its point is that they have very specific select set of students to work on. It's more of design-based curriculum. Okay. But the point is, what I'm trying to convey here is just look at what they are doing, and then I'll speak a couple of words on that. The task that they are given at the first semester that they join in the college is to design nature. Okay, so they have to look at nature and mimic what is happening in nature using mechanical processes. All right. Are you able to hear the audio?
No, sir. No, sir. The audio is not playing actually.
Oh, sorry. Just a second.
Points for solutions. Student viable solution faster.
Yeah, it is
it's
audible.
Also an important thing that allows students to learn to be more inquisitive about the world around them and to look around and pull from nature ideas that might be starting points for solutions.
There's two major components to the course, each is half of the course. The first project students do as individuals, and the second project they do as a team.
The first half of the class is called the Hopper Project, in which each student has to design for themselves and build for themselves a hopper, something that replicates some sort of biologically inspired movement.
And in order to do that, they learn a design process that involves first doing research, including things like going out onto the grounds of Alumni College and finding insects and drawing them to learn from them, but also reading scientific papers and understanding how these insects work in nature, and then using that as inspiration to build a little mechanical hopping device.
On a hopper day, every student is given 3 minutes to showcase their hopper. The class measures it, photographs it, and celebrates it, regardless of how successful it was or not. The second half of the course is what we call the play experience.
They go through a design process again, but this time they go through it as teams. The bio-inspired play experience they're creating is more complicated, an experience that's modeled after the behavior of a specific animal, but it's also being built for actual users.
At the end of the class, about 80 fourth graders from a local school will come in, actually play the students' games, and grade the students on the quality of their games and the quality of the experience.
Actually designing something for people rather than for myself as an engineer was like a skill that we had to learn and explore.
And it's all about gaining feedback and just improving, iterating on your previous design, and then eventually finishing with a product that you feel sort of fulfilled all your constraints.
This is not a course that would be recommended recognizable as like a hard engineering course at other schools. And in fact, it draws really heavily on things like industrial design. They all get exposed to the shops of fabrication because they end up making it themselves.
We talk a lot about team health in Design Nature. It's one of the core elements of the class, and you really see that at the end of the class when students have to work together to finalize a product. It's amazing to see them navigate that together in a successful way.
It's truly one of the most collaborative classes I feel like I've ever taken in my entire life. We really do learn by doing.
I want them to be able to look at everything that's happened in the semester and realize how much they've accomplished and how far they've come. Obviously, lifelong practice in design.
It takes students who feel very confident in their ability to do well in school, and it teaches them that they can do amazing things in new ways that they didn't know they could do.
There's a saying here where like it's the most amount of work you'll do and with the most amount of fun. And I didn't really believe that at first, but going through at least my first semester, I think that's absolutely true.
So what was the point about me showing a project of All-in College USA? The point is about the experience that the students go through. Okay, so the point is, it all is your motivation. If you have the motivation, you can design a hopper project. You can design a project that will mimic nature. You can work. So the whole, what's the point about the thing? All of that was in the first semester. All right. They are able to. So what's that they learn to work as a team, get things done, achieve things as a team. What they didn't know for themselves, they work together to accomplish. And what is it? Design for a human being, meaning to say for somebody else. So the experience, human experience design comes into play. So when you work for the community, work for the nature, work for the villages around you, trying to solve a particular problem, then you come together and you get the experience and you learn to do what you are not able to do as an individual. So that's the key point that we are trying to convey there. Okay, so the whole point is you will be able to tell to your friends, tell to your thing. So what did the professor end with that? He said that experience of doing something in your first semester opens up the path that it is a thing that stays with them for life, of lifetime for design. Okay, so that's the point that you have to do with respect to any part of engineering, especially computer science, where all the things can be done much easier without those mechanical stuff, because you will do most of it on your computer. Okay, is easy. Okay, doing it is much easier, and accomplishing that is much possible. I don't know whether so is it all actually possible? Is it feasible? It is implementable. Can I do it? Will I do what I do succeed? I'll tell you another example. You will come across maybe sometime later in the semester. You will attend some conferences or activities or vibrants or something, or maybe you did it also in the talent in the first orientation class. If you have come through Chennai, so our students, all the club activities, all the conferences, all the online things are done. Registration is done via workshops that we conduct is done via Chennai events website that we've got. Okay, what's special about that? That was developed by a few students. Okay, that was developed by the couple of students in their third year at the campus. They developed that website for their problem. So what they were members, students who are helping out the clubs to register the students. Okay, so what did they find? I have to do this pen and paper stuff, or I have to do this bills. I have to do. I have to keep cash account of the money, tally that, give it to the coordinator, give it to the accounts. All of that was a problem that they faced. So what's the solution they came up with? Why not develop an automated website that takes care of all of that? So that's what they did. They have a problem. They found a solution to the problem. Okay, so they came up with this website that registers students, pass it on to the club coordinator who conducts the events. That then they took integrated payments to it. So money, 50 rupees, 100 rupees, 200 rupees, whatever the registration fees comes easily. Absolutely, that's the only way you can register. So it's the accounting is proper. Easily send it to the accounts office, generate the bills, send it off to the students. All of that is done by who? By the students. And what happened after that? The guys passed out and they now made it as a company. So that website is now hosted and it offers such services to multiple other colleges. Okay. So so what turned out as a problem to a solution, to an implementation, and to a company. That's possible. Okay. So that is by making your hands dirty. So the point is you have to get involved in it. All right. It's not that I came, something was taught, I learned it and I regurgitated it and I got my marks and gone. No. That doesn't actually help you at all. Okay, so it will not suffice your needs. That's the point I'm trying to tell you. Okay, I will share you another screen. This is our Chennai website. I am now at our computer science notable alumni. All right. So this is the page that you see in our computer science department's alumni that is there. Okay. So what are these guys doing? I'm not very sure. Maybe some of you have talked to some of them have talked to you over the orientation, or the head of the department may have highlighted some of them. Quite a lot of them were my students. These are all the early batch. These students are all the early batch students, 2010-11. Okay, let's talk about these two guys. Okay, these two guys work together on this. I am talking about 2012. Okay, 10 years back. 10 years back, these are just second year students. At the time, I think they wrote the paper, it was third year students. They started working on image processing tools. They worked with a professor and they published a paper. Not one paper, two papers. Okay, they published two papers in a conference in America. And one of them got a travel grant to go to America by the conference chair, to travel grant to go to the America and present the paper. This guy also won for the first time in VIT's thing. We had the Canada MITAX internships where you can go and work in a professor with in a Canadian university global internship program. This guy went to America and then from there to Canada to complete his internship on the third year and come back. Okay. This guy, both of them wrote the papers together. All right. So since the travel grant was one, so the point is, 10 years ago, students are doing research at VIT Chennai. They are the first batch of students. They have no seniors to guide them. Okay. They were the pioneers. They put the track. Now, this last year when we took statistics, we had about 200 plus undergraduate students who have done published papers in our campus. Okay. So that's so the student take the opportunity, work with the professor, do research, and they publish papers, because of which they go ahead and study abroad. This guy is working in a university, in a company abroad. This guy went on to do his master's and PhD in University of Illinois at US. Okay, so if we click them, it will come. Saurabh Jha. They were in 3 of my courses. All right, this is the first batch of student. He recently completed his PhD there, and he's joining at some other university as a professor, assistant professor. Right? These guys are all 9 pointers. Right? So that is an advantage of being a 9 pointer. You get a good grades. Attendance criteria is waived, so you have time to do more projects. So you do well in your studies, in your curriculum, in your coursework. You have more time to do, and you are able to do something. Let's talk about this guy. This guy, Madhusudan, is not a 9 pointer. All right. I would say I'm not very sure of his final GPA. He was in my couple of my basic classes, computer architecture and in operating system. All right. So if you notice that he's he's a very shy guy. Inside the class, he will not talk at all. All right. Outside, the moment I finish the class and come outside to the corridor, he will talk and ask me questions on architecture that I have not taught in the class. Okay, he'll ask some pointed questions that I had not discussed in the class at all. He will ask solutions to the problem. What is the thing? And I need to explain to 5 minutes on the corridor. He will not go to the next class. He will be talking to me on the corridor, asking questions. If you look at the answers that he writes in the thing, so if he knows so much, what's the point? He has read the book. He has read the book. He reads it before I teach. He looks at some other IIT professor's computer architecture class. He asks questions that he didn't understand there to me. So the point is, he is doing more than what is being delivered in the classroom. And he's asking questions. But knowing that, okay, if the guy knows so much, probably he will do write great answers. No. He is least interested in that writing part of it. All right. So his grades will not, he will not be a 9. He's not a 9 point. He did not get 90s in my class. But the ability to learn by himself, to do more and beyond by himself was what was great about that guy. So why is he here? He joined a company and for when COVID first broke out, all right, he did molecule discovery that will help in attack the COVID virus. Okay, so that's what he did. After, of course, he had, by the time COVID struck, he had passed out and in the company. So he didn't go through a formal process of doing drug discovery. At Chennai, we don't have biotechnology. We don't have bioinformatics. We have it at Vellore. But this guy, on his own, the ability to learn. So that's where the first point comes. He studied more than what is taught in the class. All right. So that's the motivation he had. So he has done so much more that because of which he's able to apply what he learned and the mechanisms that he learned during the college on a problem that struck the world and found some molecules that can help probably in COVID, attacking the COVID virus. That's the capability of the student. So that is your capability. That is what you can do. That is what you shall be able to do if you make use of all the opportunities that are there. So, but all of that comes by doing. So all of it is doing by hand. You have to get your hands dirty. I'll tell you about 2 of my current properties. All right. My not your batch, the 2 batches earlier. They are currently in the 3rd year. One of the guys, I will not use names, but one of the guys, computer science, so computer related networking problems or installation problems or software problems or something that you have a problem troubleshooting your computer. Okay, that's what he is good at. So what he did, he is currently in the 3rd year. So in the 2nd year itself, he has been doing this for himself and his classmates in the class when he was physically here. And then what he did, he started his own portal online where he told, I will solve your troubleshoot your computer and fix whatever problems you have got. So he's doing computer troubleshooting sitting in India for clients abroad, to persons abroad. He's advertised his service and done. Now he has got 4 or 5 employees under him. He's a 3rd year student. He starts his problem thing, and last time I talked to him, he told, "Sir, I have earned I earn about 3 lakhs per month." Okay, so he is earning about 3 lakhs per month. He's giving to his other 4 employees, and he makes a decent profit. All of it for only one thing: troubleshooting computers. He's only in his 3rd year. He started doing it in the 2nd. So troubleshooting we don't teach in computer science. I am not going to teach you computer troubleshooting, but the point is there was a problem. He had a problem. His friends had a problem. He put his mind to the problem. He concentrated on the problem. He solved the problem, and now he has a business because of the problem he solved. That's the point. When you get your hands dirty. So what will we at Chennai? We'll give you the environment to do. We'll give the knowledge, understanding to do. We'll give you the basics to do. We'll give you the mechanism to work as a team to do. But you have to bite the bullet. You have to take the step. Your you should have the vision. So the first thing to do problem solving is to have a desire. So you should have a desire. You should have a vision. You should tell, okay, I'm going to do this. Okay, so once you have decided to do a particular thing, then you can break it down into steps and what needs to be done. Okay, so how to solve that particular problem. Okay, so that's how you approach. You may not have the expertise. Your friends may have, or your professor may have, and you can approach the professor and attack that problem, solve the problem. You could get a patent, you could get a research paper, you could be studying abroad, you could be working in a design company, like this guy working on. This guy is the most notable, popular guy who does security debugging. Okay. Finds faults in websites or web services. So he's basically a bug tracker. Okay, so white hat hacker who's won thousands of dollars from all the popular websites on the bugs that he found and reported. Okay, so that's the. He has helped us even VIT Chennai. He has helped even some issues that we had on our sites. He has helped VIT also. So he was our first student. So that's the motivation that can happen. So what I'm trying to convey to you all is that if you have the desire, we have the environment, we have the expertise, we have the mechanism to help you. We will guide you, we will coach you, we will handhold you, we will lead you right from being able to solve the particular. It need not be everything. Need not land up in a company. Okay, it's not possible. But if you are doing something small, okay, if you are doing a project for your studies, let's say you did game programming. You are learning a course on game programming. Do a good thing. Develop a good game. Game programming. I remember last year. Yeah, a student who passed 2 years back, passed out. He came back to me to ask for a letter of recommendation to apply for university abroad. He's working in IBM. He gave him a LOR and he is now joining, if I'm correct, CMU. On an AI program, a reinforcement learning program. Okay, where that in the lab that is doing reinforcement learning. Okay, so that's the task. So why I brought it up is that student when I at Chennai, VIT Chennai, when I first offered my machine learning course. So that was the first time it was ever offered in Chennai campus. When I offered the machine learning course, these two students were part of the course. Two students joined them. Okay. Before they joined itself, there was a Kaggle competition, not a Kaggle competition, there was a competition by Cone Elevators in India. They won that competition using machine learning. So they sat in my course on machine learning. Before they came to learn that, they had already studied machine learning on their own. Okay, they had already undergone Andrew and Jesus course online, and they were sitting in my course. And probably they were sort of testing out how this professor is teaching. Okay, but it was a creditable course, so they did it. When they joined my thing, I told them this is the competition that you will have to join, a Kaggle competition. They won a Kaggle competition. No, not they won. They came fourth in the competition, doing Russian, solving some Russian language, like a natural language processing task. After that, they won the IBM award. One guy got placed in IBM one guy went to CERN in Geneva. That laboratory, Large Hadron Collider laboratory. Then that guy went on to finish his masters. This guy is going to masters this year to CMU. Why I brought that up is that guy in his second year he developed this runners will be there, no? In your games, Android games and all, you will have this constantly running type of activity, correct? So that background that creates innumerable background runner type of backgrounds. Okay, that is what he developed. He didn't develop the game itself, but he developed the base that you can use it in your games. That he put it on the Android Play Store, and he told, I have earned about a lakh rupees, 1 lakh rupees or more than 10,000 downloads. and I've earned some large quantity. Okay, I don't remember the exact amount here, but it's in a large number. In second year of studies, so what is it? Learn by doing, and if you do, you can make money out of it. You can put it in a Play Store and you can make money out of it. That's the capability that the students have got. You have that capability. You can tap your potential. We will give you the environment to do it. And if you tap that potential, you will be able to excel. Okay. And you notice that the number of students who join master's program, the number of students who join companies, big companies, super dream offers, or the number of people who join MS, PhD, or the guys who do the startups. All of it is it comes by doing it yourself. You cannot be a pure science book. I'll tell you another example, a contrary example to what I'm saying. Okay, we also had a student who was very good in research. Okay, he was excellent in research. He was a 9.4, 9.3, 9.4 out of 10, something like that. That's the grade he has got. Class topper in the branch. Okay. Then came super dream companies in placements. He didn't get the super dream job. He got the dream offer. Okay. He didn't get the top-notch super dream offer. He got the dream offer. Okay. One level less. Okay. But the enthusiasm, the effort that the guy put is enormous. Okay. But he was a research bent of mind. So he went to a company that gave him a research opportunity. He didn't go to the plain vanilla software thing. So that was the super dream office generally do that coding type of stuff. But this guy was research bent, so he went after them. So the point I'm trying to make is that the grade is not the cutting criteria. All right. If you get the grade 9 point, a lot of good doors open. Like Microsoft comes. You have to be above a certain grade, all right, 8.5 and above. Okay, so that's what helps you to open the door. Sit in the placement itself. Okay, if you're 9-pointer, you don't need to write exams, written exams in some of the companies. And if you are 9-pointer, you are able to not be bothered about the attendance criteria. So all of that advantages is there. All right, so be a 9-pointer. Okay, but grades alone are not the criteria to judge yourself. You will have people, we have students who don't have good grades, but are excellent in certain things, all right? So, does not matter as long as you have the motivation, the will to attack a problem, solve a problem, we are there to help and we'll help you succeed, okay? So that's the whole point. But in all cases, do. Okay, in later semesters, in second year onwards, you can actually, instead of elective, you can take a project itself. Okay, so that's one facility that we've got in the curriculum. So instead of doing that 4 electives mandatory, 3 to 4, 15 credit worth of 12 credits worth of, no, now it is 15 credits worth of electives. You could also substitute it by a project, a 1 semester project, which can land up in more hands-on experience, and you can do wonders. Okay, so that's the facility that we've given you in this curriculum. Okay, but as part of your coursework, some faculty will give you some projects, or you invite projects on your own. You ask for an activity. So all of it is activity-based learning. Ask for an activity that will help you crystallize what you have studied. So whatever you study in the theory, you're able to implement on hands-on. Then what will happen is it will stay with you for life. Okay, so that's the best point that I want to tell. Okay, unfortunately, there were so many questions I would have expected, but I am somehow constrained not to be able to interact with you. Maybe if there are something points that you can consolidate it, put it to your head of the department who can forward it. Maybe I can answer it later, some mechanism. But the whole point about the entire discussion that I had with you, or the videos that I showed to you, was for you to do something or more hands-on. Don't skip the opportunity to do hands-on. Even if there is not an activity in your classroom for that particular subject, try to implement whatever you're learning hands-on on your own. Okay, take the guidance of the prof. Prof will always help you. Okay, do more, learn more, and definitely you'll excel. You'll outshine everybody else in your class. All right. So that's the whole point about this. Okay. I hope I was able to convince you to take a process of doing project-based, activity-based learning, and if that actually happened, then I'm satisfied with the outcome of this discussion. Unfortunately, like I said, it was more of a one-way. There's no discussion. We couldn't have it. But anyway, with that, I stop.
Yeah. Thank you. Yeah, thank you, sir. Thank you very much for your taking time off your busy schedule and inspiring our students to believe in their abilities and probably address on solving problems on their own and coming up with further discussions. I hope the students are following the points that you had mentioned, and we believe that they will turn up to us with their own showing up their skills further in the upcoming semester. Thank you very much, sir. Thank you once again.
So all of you catch Professor Balasubramaniam. He also is in the center. He will help you out in so many things. Don't let him go. Okay. Okay. Thank you, sir.
Thank you very much, sir. Yeah. Thank you, students. Thank you for joining. Have a nice day. Have a great weekend. Yeah. Thank you. Thank you all. Thank you, sir. Thank you for that. Yeah.